Hello friends, this is solving 2024 question paper part 2. Okay, let's discuss about question number 15. Question number 15 is the electronic configuration for calodium GD is outermost configuration is 4f7 5d1 and 6s2, whereas GD2 plus is here they are asking the configuration of the GD will be this and what will be the for GD2 plus. Just by removing the outermost of two electrons, since it is GD2 plus, we will get the answer, that is this. Since here 6s2 is the outermost electron, since it will hence 4f7 GD1 will be the right answer. Next, for question number 16, which of the following statements is incorrect? Okay, here they are discussing about the Slater determinant. First of all, we have to know that what is Slater determinant. Slater determinant is the matrix or determinant which contain number of series. Here, this is the Slater determinant. Here, there will be the A, like this. Like this, there will be the determinant form is produced, that is called as Slater determinant. These are the some of the functions of Slater determinant. And here first determinant is will be the Slater determinant is an anti-symmetrized wave function. Yes, it is anti-symmetric Fermi Ionic wave function. This is the correct. Okay. And now secondly, electronic wave function should be represented to Slater determinants. Yes, exact electronic wave functions can be exported as a linear combination of Slater determinants. They are the linear combination. Here the electronic wave functions are represented. Okay, this is also right statement. And next, we will skip the third one. I will go to the fourth one. A Slater determinant obeys Pauli's exclusive principle. Yes, it will obey Pauli's exclusive principle. That is, no two electrons will have same spin state. Okay. Here they are saying that a Slater determinant always corresponds to the particular spin state. But this is the wrong. So this is the incorrect, because these both are the universal to each other. So that I always telling that don't see just only question, but also see the options, because from the options only we can identify the what will be the incorrect and what will be the correct. These both are the inverse to each other, so it will obey the Pauli's exclusive principle, but it is not always correspond to the particular spin state. So third one will be the incorrect for the 14th question. 16th question. Okay, the highest occupied molecular orbital in N2 and O2 plus represented as a x-axis. Here they are asking about the HOMO theory, highest occupied molecular orbital theory. Okay, by this we can, they are giving the N2 and O2 plus. Here there will be the some of the theoretical points are there. Means this is the lighter molecule and this is the heavier molecule. Means there is a differentiation between lighter and heavier for B2, boron, carbon, nitrogen. For these there will be these are called as lighter molecules, and here pi 2p is smaller than that of sigma 2p. This is the main concept, theoretical concept. And for the heavier, which are the more than atomic number more than 8, for that O2, F2, N2, for these it may be N2, not into neon. For neon, for these elements, it will be sigma 2p is less than that of pi 2p. This will be the condition. You always remember these two conditions. Okay, if the pi is lower state and sigma is upper state, then automatically pi star will be in the upper state and sigma star will be in the lower state. Understood? If in case of here pi is greater state, sigma is lower state, then sigma will be in lower state and sigma star will be in higher state, and pi star. Only by understanding this, you can predict the highest occupied and lowest occupied state. Okay, here they are asking about the N2, means for N2 which sigma is greater. For N2 sigma is greater, so that here for N2 highest occupied will be the sigma, this sigma 2px, and for O2 pi will be the highest occupied. So here in the options what will be there, pi star 2py will be the highest occupied. So that for N2 and O2 this will be the correct option. For this question you always remember that for N2 always sigma will be the highest state for N2, and for O2 pi will be in the highest state for O2. Here they are representing O2 plus. Okay. Next question will be the 18th question. The energy levels for cyclobutadiene are alpha plus 2 beta, alpha, alpha, and alpha minus 2 beta. Here we have to know that this will be the cyclobutadiene, right? And here they are mentioning for alpha, alpha, alpha plus 2 beta, alpha minus 2 beta, right? And we have to predict that this will be the just write first plus and next minus. This will be the highest, and this will be the anti-bonding. These are the non-bonding, and these are the bonding. Whenever there will be the question asked like the for the delocalization of the energy, and they are asking about the energy levels, then we have to make like this for bonding, non-bonding, and anti-bonding. Okay. If we made like this, then non-bonding have, there is no electrons in the anti-bonding, so that 0. And for non-bonding there are 2 electrons, and for bonding there are 2 electrons, hence 2 into 2, since there are 2 alpha. Okay, then the condition will be 2 into 2 4. Okay, 2 alpha plus 2 alpha plus 2 into what will the alpha plus 2 beta, which will be 2 alpha plus 2 alpha plus 2 beta, which will result into 4 alpha plus 2 into 2, it will be 4 beta, like this. 2 alpha plus 2 into alpha, 2 alpha into 2 into 2 beta, 4 beta. The overall will be 4 alpha plus 4 beta. And this is the delocalization of the energy. And for pi orbitals we have another 2 orbitals, which will be the alpha, so that it will be the minus 4 alpha minus 4 beta, which will be the cancel out, and at the resultant we will get 0, so that the correct answer will be the first, which is 0. So first we have to consider the cyclobutadiene orbitals, and next we have to consider the pi orbitals within that. Okay. In the 19th question. Okay, next question is the 19th question, that is the product of the symmetry elements, that C2x into sigma xz is equal to. So they are asking about the product of symmetry. It is very easy, since they are asking about the C2x into sigma xz. So here the sigma xz is equal to, we have to take the minus sign, which there is the absence of number here, means x minus y z. This is sigma xz. Since there is a missing of y term, we are taking y as minus, and into C2x. C2x means x minus z and xy minus z, like this. Once we have to take y as minus and another time z as minus by keeping x as constant, since C2 x is there. So that since these both are same, we will consider only this x, y and minus z. Okay, here minus z is, there is minus z, so that the answer will be the xy. Since there is no presence of z, so that here minus z is taken. This is the resultant option. Okay, here the option is here, fourth one. Okay, the 20th question will be the point group of the ferrocene staggered is. So that in ferrocene there are two types. One is staggered and other one is ellipsed. So that here these are the structures. If both end are the in opposite direction, then it is ellipsed, which is normally used. If both end are in same direction, like this, then it is called as staggered. For ellipsed, it is d5h. For staggered, it is d5d. Since there are 5 groups, it has the 5 symmetrical operations. Hence, it will be the d. This d is also called as a dihedral plane. This d is called as dihedral plane because here Cn and NCn are perpendicular to each other. Also, here there is the h, means there will be the horizontal mirror of the plane, means sigma h will be the perpendicular to principal axis. Hence, here the d indicates the diagonal matrix, diagonal mirror, which is same as sigma v. So that in this question we have to know about this all the concepts. If we know these all concepts clearly, then it is easy to attempt these like questions. So point group will be the fixed question in almost all every exams. So there will be the 1 to 2 question on point group. So answer will be D 5D. This is correct answer. Okay. Next, 21st question. If the component of the orbital angular momentum along the molecular axis of a heteronuclear diatomic molecule is non-zero, the rotational vibrational spectra will be. If they are asked about the rotational vibrational spectrum, then we have to know about the PQR lines. PQR lines is what? Those are the lines which represents P is for -1, Q is called 0 and R is equal to 1. These are the PQR lines. For the delta J selection rule, if it is 0, then this Q will be the forbidden. But here delta J is not equal to 0. They are telling in the question it is non-zero. Molecular axis will be the non-zero. So that here the P is equal to -1, Q is equal to 0 and R is equal to +1. These three also will be allowed. So that if delta J is equal to 0, if selection is equal to 0, then Q is forbidden. But here they are telling that it is non-zero. Hence here Q will be the allowed transition. So that here all three branches P, Q, R will be allowed, since here it is non-zero, hence all three are over here. Okay, The next 22-second question are the number of rotational symmetric axes for triclinic crystal system is. They are telling about the triclinic rotational systems. So that there are many types of the rotational systems. These are the direct theoretical questions: monoclinic, orthorhombic, cubic, triclinic, like this. There are zero rotational symmetric axes. Okay. Next question, 23. 23rd question. Which of the following properties are the characteristic of an ideal solution? You always know that ideal solutions are the spontaneous reactions. So for ideal solutions there are some conditions that are always delta H is equal to 0. Hence there is no change in enthalpy. Sorry, there is no change in enthalpy. No change in enthalpy. And also delta V, which will be the total net volume. Delta V is there is no change in volume, and there will be the increase in entropy. Entropy will be increased. Hence, if entropy is increased gradually, delta G will be decreased. So these are the conditions for spontaneous reaction as well as ideal solution reactions. So that by taking these, what, delta H is equal to 0 means here delta H will be negative. Okay, delta V is equal to 0, hence delta V will be positive. So this is wrong. Delta S is greater than 0, so S is positive. So this is right, this is right. Delta is less than 0, so it will be negative. So this one is right. Sorry. Delta S is 0, but here they are telling negative. There is no less than. Okay, so this is wrong. So 1 and 4 is correct. 1 and 4 is correct. These are the characteristic properties of ideal solution. And next one, they are telling 24th question, for a van der Waals gas, the partial derivative, that is dou u by, okay, the van der Waals derivatives, that is dou u by dou v, by taking t as constant. What will be the van der Waals derivative, partial derivative for van der Waals? If we come, there is a partial derivative, then you have to remember the Sackur-Tetrode equation. Sackur-Tetrode equation. It is always related to partial derivative, but here they are asking about the for van der Waals. Okay, for van der Waals, let's take, for according to van der Waals equation, P is equal to, we know that RT divided by Vm minus B minus A divided by Vm square. This is the most important van der Waals equation. You have to always remember this equation, that is P equal to partial derivative is equal to, this is general van der Waals equation. So using thermodynamics, what will be telling delta U is equal to delta V, so that volume is changing by keeping temperature constant, that is equal to T into dou P, changing the pressure, into dou T, keeping volume constant, minus P. Once we have to keep a temperature constant and differentiate pressure, and another time keeping pressure constant and we have to differentiate temperature, but it will be negligible. Okay, now we have to do T into T divided by Vm minus B minus A divided by Vm square, that is equal to R divided by Vm minus B. So here, keeping pressure constant, we have to differentiate delta T by differentiate T, and also we have to keep this constant aside, and then by substituting the value here we will get dou u by dou v into T, that is equal to T into R divided by Vm minus B minus R divided by minus A divided by square. So this is the equation for van der Waals equation. So at last we will get A divided by Vm square, which will be the solution for this. Okay. Here what A divided by Vm square, that will be the right answer. Next, for 25th question, the molar entropy of mixing liquid A with liquid B is positive R ln 2. The excess molar entropy of mixing 1 mole of liquid A with 1 mole of liquid B is. So they are telling about the for 25th solution. We have to first know that what is molar entropy. Molar entropy is that the Na moles of A and Nb moles of B by taking the number of moles of A and number of moles of B. This is the total, delta S total entropy. Okay, by dividing this total entropy by 2 will be the molar entropy. This is the molar entropy, but they are telling the excess m molar excess, that is m real minus m ideal, which will be the molar excess entropy. So that real minus ideal. Hence, for the ideal solutions, the actual entropy mixing will be always 0, because there is no excess entropy. There is no excess, or because here the ideal solution will be always property will be 0. Excess property will be always 0. So that excess property is equal to 0. Hence, here the answers are, options are minus 2 or ln 2. This minus 2 ln 2 are from the delta S total. This is by taking the total, by adding the plus 1, and from adding this to liquid A of 1 and liquid B of 1 to this coefficient, we will get 2. Are you getting? 1 plus 1, A plus B, that is equal to 2. 2 into R ln 2. This is the total entropy of the liquid A and B. So this is the wrong. In a tube, the total entropy will be this 1 plus 1 2, and add to this 2R ln 2. This is total entropy, and this will be the 4. This is wrong. And also R ln 2, this is the initial of the mixing. Liquid A and B entropy will be this for the mixing, but excess molar entropy will be 0, because for ideal solution the excess property will be always equal to 0. Okay, for 26th question, the temperature dependency of vapor pressure of solid A can be represented by this, and for liquid A is okay. For solid A, this is the representation for vapor pressure, and for liquid B, this is the representation, and they are telling about the triple point. Okay, first we have to know that what is triple point. Triple point is the temperature in the where the uh, pressure, volume, and vapor and solid will be equal. Means here it will be the point. It is the unique temperature. It is unique temperature and pressure where solid equal to liquid equal to vapor. This is triple point. This is triple point. So that here we have to take the log P into solid, that is equal to 10 minus by T, right? Okay. For log P liquid, that is equal to 8 minus by T. Take this as equation 1 and take this as equation 2. By equating equation 1 and 2, we will get 10 minus 8, that is equal to T minus by T, which we will get 2 is equal to 400 divided by T. So that at last we will get T is equal to 400 divided by 2. 1 cha 2 cha 0 0. So 100 T is equal to 200 Kelvin. That's all. This is the solution. So by making the equating the both equation 1 and 2, we will get the answer. This is the triple point solution, like this only. So here 200 Kelvin will be the right. Okay, for 27th question. Through a constant shift of a energy levels, system changes the partition function. The properties that do not change are. So they are telling that for the constant energy level changes, by changing the energy levels, some of the functions will not change. So they are asking which partition functions will not change their properties. Okay, first we have to know that what are the these average energy, entropy, and heat capacity. You have to note that. Okay, here know that 3 by 2 RT will be, please remember these equations. Average energy, for average energy, and for entropy, cyclobutadiene equation. You already know the cyclobutadiene equation. It is in 4th sem of MSc, which is for partial derivative for entropy. Yes, and here Cv is equal to 3 by 2 R for heat capacity. Here T is there for temperature, for average energy. So this temperature will be varying, and these are the constants. These will not change, entropy and heat capacity, since we know that in cyclobutadiene equation there is the PQR, which will be the constant, means delta P up to infinity, that is equal to delta Q delta R, like this. There will be the cyclobutadiene equation. There is, hence there is no dependency of temperature, hence this is also constant and this is also constant. So average energy will changes, but entropy and heat capacity will not changes. So that here the options are average energy, entropy, heat capacity is wrong. Average energy is wrong. Average energy is wrong. So entropy and heat capacity, yes, this is the right. Okay. Next, 28th question. 4 distinguishable molecules are distributed in energy levels E1 and E2 with degeneracy of 2 and 3 respectively. The microstate. microstate with 3 molecules in the energy level E1 and 1 in energy level 2. So 3 molecules in E1 and 1 molecules in E2, which are there in 2 and 3 respectively. So that they are telling for E1 we have 2 generacy, yes, right, and these two have 3 molecules, right, and for E2 like this, right. Okay, degeneracy will be for E1 it will be 2, and also there are 3 molecules, and degeneracy for E2 will be 3 and there are 1 molecules. So this solution will be 8 and this is 3, but the total molecules are 4. So total there are 4 and we have 8 for E1 and 3 for E2 into 4 into 3. It will be 96. Finish. It is so simple problem. So this is the way to calculate the microstate. This is for microstate calculation. Like this, by using this type of the tricks, we will achieve in the KSET examination. Okay, which will be the 96 will be correct. Okay, 29th question. 2 moles of MnO4 minus plus 5 moles of, there is the reaction, and they give the E0 for the cathode and E0 for the anode. Okay, E0 anode and cathode for the negative potential and positive potential. Okay, so that they are telling the calculate the equilibrium constant. Oh, equilibrium constant K. Okay, for 29th question. 29th question, equilibrium constant K. Okay, log at base 10 K, that is equal to ln K divided by ln 10. This is the general form of K, you all know that. So that what is ln K? Ln K is equal to NF E0 divided by RT. By the Nernst equation, by using the Nernst equation, we can find this equation. Okay, what is N? What will be the N? Here we will use the, here we will use Mn. So there are 2 moles of Mn are utilized and give product to the 2 Mn. So Mn charge will be 5. 5 electrons are there in Mn. There are 5 electrons. So for 2 Mn it is into 2, so that 10 electrons. So N is equal to 10. And for E0, here for E0, what is there? 1.51 and minus 0.49. Okay. 1.51 minus of minus 0.49, which will approximately 2 volts, right, which is approximately 2 volts, means here 5491, which will approximately 2 volts by putting this as E0. So that 10 into Faraday's, what will be the Faraday 96485 into 2 divided by 8.314 into temperature it is given 298. By solving this we will get 338.26, right. Calculate this that time, so that this is the for ln K, right. This is for ln K divided by ln 10 overall. This log into base 10. For this is that 338.26. Log base 10 K is equal to 338.26. Okay, for K we will get log of log, or else we'll just write 10 raised to 338.26 like this. This will be the answer. By taking the simple log base 10 is equal to k, that is equal to ln k divided by ln raised to 10, we have to know the ln k. So by taking the ln k, that is equal to nf E naught divided by RT. N will be the for Mn 10, and F is the Faraday constant, and E will be the this cathode minus anode. So 2 volt. By all putting the all constants here, we will get some number that's like 778.87, and by dividing by ln 10 we will get 338.26, and by converting this log base k like this to k, we will get 10 raised to 3.326, and here it is 10 raised to, that is 2 is correct answer. For 30, ionic mobilities of NH4 plus and HCO3 minus are this 6 into 10 raised to minus 4 and 5 into 10 raised to minus 4. Calculate the transport number of NH4 plus and this ion. What will be the transport of this ion? This is also very simple problem. You have to just know the how to solve this type of the simple problems. In physical chemistry, these simple problems are make most difference. So this is for 30th question. It is very simple problem. See, for 30, we know that T positive divided by T positive minus T minus, like this will be T minus divided by T positive minus T minus. Simple problem. What there is a given for positive term, we have to make positive divided by both minus, and negative term opposite and taking or below this difference, like that only. So that for 6 positive divided by 6 minus 5, it will be 11, and for negative it will be 5, and 6 minus 5 it will be 11, right? 6 by 11, 5 by 11, it will be, for 6 by 11 it will be 0.55, and for 5 by 11 it will be 0.45. Finish. Here just the ion transportation they are telling. So this is the decomposition. It will carry out the decomposition. So 6 by 5, 6 divided by 11 and 5 divided by 11, so 0.55 and 0.45 here. Fourth is the right. So simple concepts are there. So make practice of this. Next will be the 31st question. They are telling what is the concentration of the reactant in the first order of the reaction. When the rate, they are given the rate of the reaction, they are given the rate of the reaction and constant. So that they are given the rate of the reaction A and also the constant K. So that we know that for first order reaction, what we know that rate is equal to K into A. This is simple Arrhenius equation, right? Or not Arrhenius equation, this is simple rate equation, rate constant equation. So we know the rate, we know the A, just we know we have to calculate the K, right? No, they give us K constant, and rate of the reaction will be 0.6 centimeter inverse, and constant rate constant will be 0.035, right? This is the rate of the reaction R, and this is the constant K. So we have to calculate A. So that A is equal to rate divided by K, that will be 0.6 divided by 0.035. The answer will be the solution, that is 17.14 will be solution. here 17.143 molar will be the solution. They are also given the solution like the 17.667. Here we can easily answerable that there is this answer will be around 17 only. Okay, next question 32. What is the value of rate of constant K if the value of activation energy EA and the frequency factor A are 49 kilojoule per mole and 9 into 10 raised to 10 respectively? If they are given the temperature and they are given the frequency factor A, and also they are willing to calculate A. So now there is the using the Arrhenius equation. Simple. By using the Arrhenius equation, that is using Arrhenius equation, we can easily solve this. K is equal to A into exponential of minus A divided by RT. Okay, we know the EA. What will be the EA? They are already given that the frequency factor are 49, right? They are given EA of the activation energy. Okay, EA is equal to what? 49 kilojoule per mole, and A will be 9 into 10 raised to 10 seconds, and also temperature they are given in the Kelvin only, so no need to convert, and also R is equal to 8.314 kilojoule per mole, right? Okay, we have to convert. Sorry, this is not for kilojoule, this is joule per mole. So this kilojoule to joule per mole, so that 49 is converted to 49,000, since we have to convert this by the Arrhenius equation, A into exponential of EA minus RT. So EA is already given, which is in the kilojoule per mole, so that we have to convert this kilojoule into mole to the joule per mole, since the gas constant R is equal to 8.314 joule per mole, and temperature is given and A is given. So by putting all these values in, K is equal to A into exponential of minus A divided by RT, we will get that A divided by RT, that is equal to 59,000 divided by 8.314 into 313, that is 18 point here, and also K is equal to 9 into 10 raised to 10 into e raised to minus a to 6, so that K is equal to 6 into 10 raised to 2 per second. This is the solution. These are the simple and most simplest problems. These are the second PUC problems in to tell that by using the Arrhenius equation we can solve the direct. By substituting the value in Arrhenius equation, we will get the problem. And here also same, by using the some of the tricks like this, we can say the probability, the ion transport system. You can say just by looking the rate equation, we can solve this type of the questions. So these are the most simplest questions. We can get 2 marks. So that here 6 into 10 raised to minus 2 seconds. So don't neglect the chemical kinetics. Don't neglect the rate equations. What 6 into 10 raised to 2? Okay, plus 2 seconds. Question 1. Option 1 is right question. Next will be the most simplest. Means here it is a theoretical concept. 33. Here which of the following is not a heterogeneous catalysis? First, Haber process. What will be the Haber process? Ammonia, production of the ammonia. Okay, here Fe solid is used, which will be the heterogeneous. Next, oxidation of SO2 into SO3. during contact process. So here these are the named reactions: Abir, contact, and water gas. We know in fourth sem it is a water gas which will be the heterogeneous catalyst. So polymerization is only Giger catalyst, is only homogeneous catalyst. Uh, uh, Without that, all the catalysis, including the mm, including all are the heterogeneous catalysis. So that here the combustion of the coal, which is the combustion reaction, not heterogeneous catalysis. The combustion of the coal is the right answer for this. And next, here 34th, the volume of the gas absorbed on a solid surface. This is 10, 11, 11.2, 14.5 and 22.5. So it is increasing. So here we have to know that it is increasing, and also at pressure is also increasing step by step, step by step. So we have to know this of the data. And here they are telling which of the data is best for the represented process. Okay, first we have to know that what is BET process. What is BET isotherm? BET isotherm is it is just measure the surface of the solid by nitrogen. How the surface of the solid is there by using the nitrogen gas we will use, and it is the fixed about the 77 Kelvin. I think it is 77 Kelvin BET is used. So this is not for the absorption of the gas molecules in solid surfaces, and there is no pressure also involved in the BET. It is for the temperature. BET T is temperature. And second option is with the Gibbs. It is the it will describe the relationship between surface excess concentration and also change in the surface tension. This is for the surface tension. This is for the surface tension, and this is for the volume of the solid. And we have two, that is Lacunar isotherm and also Federling isotherm. Okay. Here for the Langlumer isotherm, absorption occurs only at the specific homogeneous sites only, not like this. Here there will be the continuous absorption is there with a constant pressure. So this is not. So answer will be the 4. Fourth option will be the correct, since it is for the constant absorption will be take place at a constant pressure. So for the future in 2025-26, these can also this can also take place. Means for which isotherm there will be the which describes the relationship between surface excess concentration and also change in surface tension. For that, Gibbs isotherm is there, and for BTA is also most important. This will be the most important BT. So questions may arise, and also this for body center. This is the theoretical question. For body center, what will be the answer? For body center, this will be the correct option. Second, 0 0 0 and half half half. This is the correct. And if we know the other options for 0 0 0 0 0 half, this is for BCC. This is for simple cubic. Simple cubic. Okay, and 0 0 0 and half half, double half, or double 0 1 1. What? These both are for I think FCC, right? Check once, but I will just write. These both are for FCC. If there is a base center, then there will be two half lines like this, 0 half half. This is for, I think this is for base center. Okay, just note these points. This can ask it in future also. So right question will be 2. Next question: the compound M and X have the cubic cell M atoms in the body and face center, the molecular formula is, so that they are telling that m and x are the cubic centimeter corners and body center. Okay, so this is the body center and x are in the face center. So the molecular formula is, so I will solve here only. If they are in the corners, so 8 into 1 by 8, right? Cancel, cancel. So 1. Next, they are in the where? In the face center. So 6 into 1 by 2. 1 cha, 3 cha, which will be 3. 1, 3. So that 3 plus 1 plus 1, since it is in the body center. In the body center also 1. So 1 for the corner, 1 for the body center, and 3 for the face center. 1, 1, 3. 1 plus 1, it will be 2, 3. So that here, we're here m2 x3, right? m2 x3 will be right answer. Mx is wrong, mx2 is wrong, m3 x2 is wrong, m2 x3 is right. Yes, this is fourth one. m2 x3 will be right. So this is also simple theoretical concepts. So these both are from solid state. So always refer this type of the questions for the solid state. And for the next question, the average molar mass Mn of the weight of the average mass of the polymer. So they are telling number, quantity and the weight. Number of the average molar mass and the weight of the average molar mass. So they are telling which of the instrument is used for this. So osmometry, which is for osmotic pressure, which is used the number of average molar mass. For this, osmometry is used for number of molar mass, and electroscattering measurements is used, right, is used for the this for railing scattering, I think railing tracing for weight of the, so one will be the right answer for 37 questions. And for 38 question, they are asking for the polymerization. There is a reaction is given and they are telling the rate constant will be this and initial concentration is this, and overall rate will be, final concentration will be this. It is very easy question. So that we know that V is equal to rate of polymerization, means the final concentration. Rate of polymerization is divided by rate of initiation, like that. Polymerization divided by initiation, so that final Rp divided by Ri. That's all. See here, what is Rp? This is overall rate 4, and this is 2 will be initial. So 4 into 10 raised to minus 3 divided by 2 into 10 raised to minus 3, that is equal to 2 into 10 raised to 3, which will be 2000. That's all. Simple questions are there. 2000 here 1, 2000 is there. Just by dividing 4 divided by 2, 2, since 2000, like that only. Now they are telling the, in a titration, the percentage of the uncertainty is measured acute volume, and the measured titrant are plus or minus x and plus or minus y respectively. The percentage error can be calculated of the, so here they are telling about the percentage error, how to calculate the percentage error. So this is overall the theoretical questions, that is this is x square plus y square half, or else by removing this half you can add square root, both are same. Okay, the 14th question, what will be 40? The represented measurement of the lead in a lake water sample is given as this 3.2, 5.2, 7.2, and the standard deviation of the measurement of the PB is. First we have to calculate the yes. What will be the yes? Means standard deviation. Yes, the formula is summation of xi minus this median divided by square divided by n minus 1. For this, first we have to calculate the, what will be the median. 3.2 plus 5.2 plus 7.2 divided by 2, sorry, divided by 3, 5.2 ppb, which will be the mean. So this 5.2 will be deviated into 3 parts, 2.2, 2.2, 2.2, and there are 3, n will be 3, and this is deviated, hence it will be for 8, means x minus this all, which will be root 8 minus 3 minus 1, which will be root 4, which is 2 ppb. This is the solutions for this 40. So here I will complete this part 2 up to 40, and in part 3 I will almost complete the another division of the 40 questions up to 80, and in part 4 overall completion of the question paper will be take place. So please follow, please subscribe, comment and like and share this video. Thank you one and all. Bye.